Hi, I'm Dave Schatz with DHS Equipment. Today I'm going to show you how I do an overhaul on a Wacker WM80 engine. This is the most common engine used on their jumping jacks and their gas breakers. To start with, we remove the engine. I've got it mounted on this jig right now. In order to speed things up, we had already taken the clutch off. There's a clutch removal tool that you can get from Wacker. It's a standard clutch removal tool. You just thread it into the clutch, remove the nut, thread it into the clutch, tighten on the bolt here, and it'll pull it off the taper. Very simple, very common. We'll remove our clutch. To speed things up, we'll go ahead and use our cordless drill, and we'll start removing this cover. Set that cover to the side. Here's our flywheel and our coil, and we're going to get into that after. First, we're going to go ahead and pull the piston and cylinder assembly. You do not need to remove the flywheel for this, but we're going to remove it anyway because we're going to do the bottom end overhaul as well. Once that cover's off, we've got access over here because we're going to need to get to this side of the cylinder. Okay, so next we're going to remove our carburetor and our heat shield. On the carburetor, there's two small bolts holding this flange on. We'll just go ahead and remove that. Gasket will pop out, the nuts, and we'll remove that whole carburetor assembly, flange, and gasket. Set that aside for later. Okay. Next thing we're going to do is we're going to remove this top heat shield. Our spark plug. We'll remove our spark plug. Slide that over there. Set that to the side. Okay, the next thing we want to do is we want to remove the 4 bolts and remove the cylinder. Before you remove the cylinder, if you're not very familiar with these engines, if you're not very familiar with 2 cycles, when you go to reinstall this piston or this cylinder assembly, you may not recall which end goes where. Is it the intake side over here? Is it the exhaust side over there? So just to remove all that doubt, before we remove the cylinder, just take a marker. This was the exhaust side of the cylinder. If you want, just put a little EX on your engine over here. This way, when you go to reassemble it, you know which way the cylinder is going, because it'll install either way. It's going to take a 5mm socket head wrench, drop it down in there, and remove those bolts. These are socket head bolts. They sometimes have a tendency to strip, especially if your socket head tool, if your Allen wrench is a little bit worn. These bolts are a little worn. It's always a good idea to go ahead and replace new bolts if you're going to redo this cylinder. This way, the next time, it won't strip. Because that head of the bolt strips while it's in the cylinder, although it's not impossible to remove, it's just not the easiest thing to remove. You've got to get in there with a drill bit, and you've got to drill out the bolt in order to remove the cylinder and then try to extract the bolt. So we'll loosen all these screws. And we just lift the cylinder off the piston. Quick note about the cylinder. If you're not sure which side is the exhaust side, when you get your new cylinder, the exhaust port in relation to the intake port is always going to be higher. Okay? So the higher side port is your exhaust side. That's going to be on the side as we rotate the engine to where we made that EX mark. Okay, the cylinder is off. Now we're going to remove our piston. We're going to rotate this around so we can get to the clips and the pin. Okay, to remove the piston, we're going to go ahead and remove the retaining clip on one side. You can see right in here. It's got the little retainer clip. Usually a pair of needle nose will do the trick just fine. pull out that clip. Now what we want to do is we want to drive that pin out. This is why we took this other cover off, so we have access to the other side. Or when it's take our needle nose, or you could use a screwdriver or anything else you like, and just press through on the other side to drive out that pin. Once that pin is through enough, we can reach around with the needle nose and we can pull it out the rest of the way. And now we can remove our piston. Between the piston pin and the connecting rod is a needle bearing. Whenever you're doing any kind of a top end repair, always replace that bearing. It's a wear item. If you're replacing the piston and cylinder, you should be replacing the pin bearing as well. Okay, piston and cylinder is off. If we were going to just be doing the piston and cylinder assembly, nothing else, we would just go ahead and reverse what we just did. But we're going to go a little bit further, and we're going to go ahead and disassemble the rest of the shore block. Quick note on checking wear on the connecting rod and checking wear on the pin and pin bearing. We'll put our pin bearing onto the pin. We'll put that assembly through the connecting rod, and we're going to check for play. There should be no vertical play at all. If there's any play up and down, something's worn, it's got to be replaced. If you do have play, we need to determine, is it the connecting rod or is it the pin and the bearing? Easiest way to do that is get your new pin, get your new bearing, and put the new pin and new bearing into the same spot, and now check for play again. If the play is gone, you know you just got to replace your pin and your bearing. If you have a new pin and bearing in there and there's still play, your connecting rod is no longer within service limits. So you're going to want to replace that crankshaft and connecting rod assembly. So what we're going to do next is we're going to remove our flywheel and our coil, and we're going to split the crankcase open. To remove the flywheel, we must remove this nut over here. This nut is torqued down, so we have to either hit it with an impact, which will knock it right off, or if you don't have air tools, you don't have an impact wrench, you could use a strap wrench and hold that flywheel snug right there and hit it with your ratchet. Or if you notice right inside here, there are some holes. Put a screwdriver into the hole and rotate the flywheel. That'll lock it right there. Do not use your fins. Don't use your fins and your coil as leverage. You'll take out a $100 flywheel and a $200 ignition coil. You're going to put your screwdriver in the top hole. You're going to rotate the flywheel till it locks. You're going to put a 19mm socket on there. And you're going to loosen that nut. Remove the screwdriver, and we can take that nut off. Take the washer off. Now we're just left with the flywheel. Wacker has a flywheel tool, fairly inexpensive, very usable tool, very easy. It'll pull this flywheel off in a breeze. There's not a lot of space to get a jaw puller, and if you were to put a jaw puller in there, this material is very thin, very soft. Chances are you're gonna snap your flywheel anyway. It's worth the while to get the correct flywheel remover tool. All you do is loosen up this back bolt. The outside of this little hub is threaded. I'm going to thread the tool on. It's only a taper fit, so it's not on there very tight. Tighten up the bolt. Hold that still with a 19mm wrench. Try to tighten it. Usually it'll pop off before you get your first thread done, and it'll pop the taper. Once you pop the taper, and you usually hear a pop, you could remove your clutch tool and your flywheel will come right off. Go ahead and set this flywheel to the side for now. Now that the flywheel is off, we've exposed the back of the back of the engine where your coil wire is, and this is your high tension lead over here, this is your ground wire over here. A lot of times, if you've got an engine with an intermittent problem, your motor's just running, it just dies, no apparent reason, you can crank it back up, run it for a few minutes and it'll die again. A lot of times, this little wire has made its way loose and hits the back of the flywheel. If that wire is allowed to hit the flywheel while it's running, it's going to ground it out and you're going to lose spark. Your engine's going to stop running. When your engine stops running, there's no more vibration and the wire's just going to be sitting there next to your flywheel. It's no longer grounding it, so you'll be able to start it up again. You'll go to operate your machine and it'll die again because that one little wire is just knocking into your flywheel or grounding against your block somewhere. So sometimes you've got to pull that flywheel just to confirm that you've got no wires poking out and grounding. Okay, so the next thing we're going to do is we're going to remove the coil. That's a little clip right here. Depending on which model machine you got, this is just a connector where the switch is elsewhere, located under the throttle lever or something like that. The older machines actually had a push button right here, which also could be a problem. Sometimes the older machines will short, and that little push button will just be grounding internally. So for troubleshooting purposes, you could disconnect your cable, or on the push button, it's a little set screw. You could remove that little set screw and pull your wire out, and then check your machine for spark again. Sometimes the problem is just right there in the button. You don't have to replace your ignition coil. Okay, so we're going to go ahead and replace remove the coil. Okay, to remove this coil, it's got these two little tabs that are supposed to be holding back the cables. Just get a little flat screwdriver in there. Get a little bit of the tip in there and pry it up just enough to release the cable. The same thing over here. You're just going to pry it up a little bit, just enough so you're able to get that cable out. The cable routes through the block, the hole in the side of the block, and it's got a rubber grommet. It's easier to pop the grommet out and pull the whole cable through rather than trying to pull the whole cable through the rubber grommet. If you just knock the grommet out of the whole assembly will come out. You'll get stopped right here though. This is where the boot is. The boot's not going to follow all the way through. So all you've got to do is pull the boot out. And we'll set that boot to the side for now. So now we got the grommet popped out. You can probably see it right in there. We've got the cable coming out of that where the little flange was, and we're just going to pull this out. Okay, we're going to pull the ignition coil out. It's just held in with 3 screws. Remove the screws, we remove the coil. We'll set to the side for now. Okay, everything has been removed. We're ready to take the case apart, pull out the bearings, press out the crankshaft, replace the bearings, and put this assembly back together. For this, we're going to need just a couple of things. If you've got a press, the press is going to be the best way to go about it for installing the crankshaft. For removing the crankshaft, you don't need to worry about a press. There's going to be a couple of special tools that Wacker has and sells, most of which are unnecessary. We could easily use a couple of items that we bought for a few dollars at Home Depot, and it's going to help you do this overhaul very inexpensively. Okay, so for now, I'm going to dismount the engine block and move over to the vise. Okay, now that we got our block off of our jig, we're going to go ahead and split the cases. This is the easiest way to do it. On the bottom of this engine, you've got 4 holes. It's an 8mm bolt. What we're going to do is, on the flywheel side of the engine, take that 8mm bolt and thread it in. Take the other 8mm bolt, thread it in. Doesn't have to be tight, it's just going to be holding up the crankcase. But you want to thread it in about 1 inch at least. This way we've got a solid fixture to hold this block up. On this side of the engine, we've got some Torx head bolts, and we've got some nuts on the other side. So we're going to start by removing these nuts and bolts. What we're going to do is, now that we've got this up, we can just hold it into our vise. take our Torx end socket and just start removing these bolts. Bolts to the side, or the nuts to the side. Okay. The next thing we do once we've got all the nuts and bolts removed, we're going to separate the crankcase halves. The outside housing is aluminum. It's thin. It's soft. It'll heat up quickly. So what we want to do is with a propane torch, just to make this easier to press out, we're going to take the propane torch and we're going to heat just this area. Okay? And once we heat that up, we're going to start to remove it. Now, anytime you're going to do anything with a crankshaft where you're going to have any kind of tools around the threads of the crankshaft, we don't want to damage them. So what we're going to do is we're going to thread the nut back onto the crankshaft. Okay, on the flywheel side and on the clutch side. We're going to begin to heat this area now. We don't want to use oxyacetylene. We don't want to use heavy duty. We don't need to melt this area. We just need to heat it up just enough to expand and release that bearing a little bit. We're just going to go a circular motion all around where that bearing is. That should usually be enough. Okay. With that nut flush with the crankshaft, we're going to take a dead blow, nothing heavy, no 5-pound sledgehammer, just a dead blow, good solid dead blow hammer, and we're just going to grab hold of this side of the crankcase and we're going to hit it squarely on the crankshaft. It's heated up, it's relaxed enough where that bearing can come out easily. If you don't heat it up, this is not going to go very well. If you put it on a press without heat, you could possibly crack it. So a little bit of heat goes a long way. So we've already got this side out. We're going to go ahead and repeat the process on this other side. Take this other side, use our 8mm bolts. We see on this side the seal already came out. That nut will sometimes grab the seal and pull it out. That's fine because we need to remove that anyway. If it did not pop out, all we have to do, rest it on its face, take a socket, or a piece of 3/4 inch PVC, just put it on top of the seal and pop it through. The seal should pop out very easily. Okay, with the same procedure, we've got those bolts up here. We're going to put that in a vise. We're going to heat this area here, and we're going to remove the crankshaft from here. Slow circular motion. Same thing. Now, again, with that nut flush against the crankshaft so we don't damage the threads, hang on to the crankshaft and give it a smack with your hammer. Almost there. Now our crankshaft is out. This section is going to be hot, so remove it from your bolts. Same as before. If the seal did not come out, lay this flat on the bench, take your socket or your piece of 3/4 PVC, and knock your seal out. While these two items are cooling, the next thing we're going to do is remove the bearings from the crankshaft itself. We can now remove the nut. We can remove the seal, discard the seal. Not going to use that again. Remove this other nut. Remove that seal. Discard that. And now what we've got to do is separate the bearing from the crankshaft itself. Take a look in here, there's not a lot of room between that bearing. There's no way to get a standard puller on there. So what we're going to use is a split bearing puller like this. Okay? If you take a look at this puller, and you can get these anywhere, Harbor Freight, Sears, Northern Tool, etc. If you take a look, it's got a little angle right up here. And what we're going to do is we're going to put this on both sides of the bearing on the crankshaft, and we're going to start to tighten these. And as they tighten, they're going to wedge themselves between the bearing and the crankshaft, and it's going to squeeze this, and it's going to start to press the bearing out. So that's what we're going to do next. So you see we've taken the bearing puller, put it on both sides of the crankshaft and the bearing. There's the back of the crankshaft, there's the front of the bearing. And as we tighten these up and it squeezes it, it'll start to press the bearing up. We'll go ahead and put it in the vise just to make it easier. Okay, just slowly tighten it down evenly. Sometimes you can aid this by taking your hammer. If you see it's already starting to pop out, you could aid this by hammering down a little bit. And as it squeezes, it's going to throw it out some. And this bearing is just about off already. If we had we still had a lot more to go to get this bearing off, we would probably go to the press, fix some jigs right here, and continue to just press right down. This bearing is just about off already because of the bearing puller. So for the most part, we could just grasp that crankshaft in our hand. Again, put that nut flush with the crankshaft to protect the threads, and we could just take it all the way through. And removing the bearing is as simple as that. This is a great tool. It helps quite a bit. They've got smaller, they've got larger. This was just the best fit for what we had. Okay. And what we're going to do is repeat the same thing on the other side, same procedure, remove that bearing as well. Okay, so the next thing we're going to do, considering this bearing was already off, now we're going to go through the procedure on how to reinstall new bearings, how to install the crankshaft back into the crankcase, and then finish rebuilding our engine. Okay, so now we're going to go ahead and install the bearings. We're going to use this small hydraulic press. It does not take a lot of pressure to get these bearings on. What I have here, just because it doesn't take so much pressure, I've got just a regular piece of PVC 3/4 inch pipe. It's the perfect fit for around the crankshaft, and it's also the perfect diameter for the inner race. So this is what I use. If you could probably use a piece of metal conduit, or of course Wacker has a special tool that looks just like that out of heavier gauge steel. This is how I do it. Works well, has worked well for years. Okay, we're going to set our crankshaft, and we're going to get it centered. We're going to put our bearing on. There is no direction to the bearing. It doesn't really matter. We're going to set it on, and we're going to take our PVC, or just regular 3/4 inch PVC, and slip it on there. And then we'll start to press that bearing on. As we get closer, we'll get a little bit better with the accuracy. It's straight on. Okay. We're going to get everything as straight as possible. Piece of PVC, the pipe, the press. See, just as easy. That's it. As soon as it seems like it's flush with that side of the crankshaft, you're done. You don't have to put a lot of pressure. We'll just stop right there. If it's off by 1/1000th and it didn't press all the way in, we'll address that later once we assemble the block. But for right now, this is all you need. We can now release it from the press. Take the PVC off, take your crankshaft off, and this is now where you would do the other crank bearing. Okay? Now our crankshaft is in good condition. We got the new bearings on there. We're ready to proceed. Back to the bench. We're ready to take this crankshaft assembly and new bearings and put it back into our now cooled crankcase halves. Okay? Just like when we had to remove it, we're going to have to heat this up so when we install it, it'll install much easier. Okay? At this point, sometimes you'll lose track of which way is which. This bearing is the same bearing both sides. You could easily put the crankshaft in backwards. Okay? We know this was the flywheel side. The flywheel has the key. So long as we know the flywheel has the key, this is going to be the clutch side. This is the PTO side, the positive takeoff side of the engine. So we're going to put it in like this. Okay, so the first thing we're going to do is get our other Home Depot tool, a regular 4-inch PVC coupler. We're going to take this right here. This is the clutch side. The clutch side goes in here. We're going to heat this up. We're going to take this assembly to the press, and we're going to press it in. Okay, so let's start by heating it up. Now once we start this, we want to act fast because as quickly as it heats up, it also cools. It's going to be harder to press and you're more likely to crack or damage the crankcase. So a little bit of heat, get it done, pressed in quickly, it'll be great. Okay, all we had to do is adjust the press a little bit. This is heated up. We're going to have the bolts towards the back so we could watch the crankshaft and we could watch how it goes in when we start to press to make sure that it goes in evenly. Just going to align that. If you heat it enough, you see how that went in? The bearing just slid all the way in already. It doesn't always do that. So what we want to do is pay attention and make sure it goes in nice and straight. Again, make sure that nut is flush with the crankshaft. Okay? As we begin to press, we're going to try to make sure we keep our alignment between the crankshaft and the crankcase, and it presses down at the same time, evenly, left side, right side. If it starts to go down at an angle, you've got to stop. If you keep pressing, you're going to crack it. If all of a sudden it starts pressing at an angle, you could relieve the pressure, go to the high side, press it down a little bit, and as soon as it's level, reposition it in the center, and go ahead and continue to press. Okay, it's fully pressed. As soon as you see some resistance and as soon as you see that crankshaft is just about touching the crankcase, that's it. Again, if you're off 1/1000th, it doesn't matter because when we bolt it all together, we'll address how to compensate that extra little bit. Okay, so we're straight. We can go ahead and release the press. Okay, now what we've done, the other side is done. We've already heated this side up. So what we're going to do is we're going to place this in the press as well. Again, with the connecting rod side out so we could watch it get guided in. We've got our crankcase gasket. Go ahead and get that crankcase gasket in there. And what we're going to do is just tear this right in the center for now. So when we set it in, our connecting rod will go through. And then we'll trim off the top when we're done. Okay. Yeah, we've put the nut onto the crankshaft. And we're going to go ahead and drop this in. We're going to keep the bolts to the back, the connecting rod to the front. The crankcase, if you see right here, has a guide pin on the left side and on the right side. Okay, that'll keep everything aligned. So we're going to go ahead and get this set up as straight as we can. Try to get this set in as evenly as possible. There we go. Okay. And now we'll just begin to press and we'll check our alignment. Okay, as we get closer, we'll make sure everything is centered. If you see your crankshaft is going in at an angle, if you see it's not going in as straight as it should be, stop and redo it. If you continue to press, you're going to snap something or crack your crankcase or do some damage. Okay, in our case, everything's going very well. I think maybe our pin is not aligned. We'll release this a little bit. Okay. We'll just tap this over a little bit. Pin is not aligned, it's not going to go together. Our pins are aligned, our crankcases are going together smoothly and evenly. Okay, everything looks good there. Okay. Go ahead and release this. Okay. Take this out, put it back in our vise, let it cool a little bit. Okay, now that we've got it out of the press, the two crankcase halves are together. We haven't put the screws in yet, but we're going to start putting the screws in now. It's still a little warm. We don't want it to completely cool yet because if the bearings are not 100% seated, as we draw the bolts together, that'll pull everything together and that'll help seat everything. Okay, so we're going to go ahead and start putting in the bolts. And we'll tighten the crankcase. Everything we do when we put this engine together is going to be Loctited. The Loctite brand or any other kind of a medium strength blue thread locker. I'm not using the thread locker on these because I'm going to pull this motor apart for another class we're doing. So I'm not going to be Loctiting, I'm not going to be torquing, but you're going to. So a little bit of blue Loctite or thread locker on all these screws. These screws are 5 pounds of torque. And you're going to do a crisscross pattern, starting on the inside and then go outside. Never go clockwise or counterclockwise. So once we start snugging the screws, if the bearings are not seated 100%, as you start your crisscross pattern, you may hear a little creak, you may hear a little noise. That's the crankcases completely accepting the bearing and seating correctly. Okay. Everything should be cool now. We want to make sure everything is rotating freely. There's no binding. And the final step to make sure everything is seated completely. Everything is torqued, everything is pressed in. Just one good tap on this side. One good tap on this side. Between the torque, the taps, this bearing is fully seated. And you'll see it actually rotates a little bit nicer now after the hit. Okay, so we're completely seated. Okay, so we're going to go ahead and cut off the remaining gasket from the crankcase gasket. We're just going to put a razor blade and just cut that gasket flush with the top. So that's it. Our crankcase is now done. We've got the gasket, the crankshaft, everything is good. The last step is the crankshaft seals. I like to do crankshaft seals last. A lot of people like to put them in before they put the shaft in. To me, there's too many possibilities of heating up the seal and doing damage to the seal, or when the crankshaft gets pressed in, sometimes could do damage to the seal. So I like to put the seals in afterwards. Okay, we're going to use our 4-inch coupler again, just to hold the engine down. We're going to grab some new crankshaft seals. We're going to grab our new crankshaft seals. What you want to do is you want to just take a little bit of oil and lubricate the inside of the seal. This way when it gets pressed onto the shaft, it goes on nice and smooth. Just remove the nut over here. Put the seal down in place. And there are seal drivers, there are sockets, there are pieces of 3/4 inch PVC that we love to use. And I'm going to go ahead and use that PVC because it's the perfect diameter on the inside and outside, and it fits right over. Just like the crankshaft bearings, you want to check alignment. If that steel starts going in crooked, you want to tap the high side, get it level, and then press it down levelly again. Okay, so we're going to just tap it in place. Check it midway, make sure everything's going well, everything is level. Tap it a little further. If you see you got a little bit of a high side, there's a little bit of room, a little bit of play. You could just bring it over to the side, hit the high side, bring it to the other high side. You could just slowly adjust it, but ultimately you want that seal pressed in. You want the top of the seal flush with the top of this engine. Okay? So that seal is on, everything is smooth, turning well, no binding, that seal is done. A little bit of oil on the inside of the seal. Get it in place, and tap the seal down flush. If you don't have the PVC, the correct size socket will also fit on there, it'll do the same thing. So that seal is flush with the top of the engine, that seal is done. Okay, now that our seals are on, that motor's cooled off a bit, we've got it mounted right back up to our jig. What we're going to do now is we're going to go ahead and install the coil and install the flywheel. Okay? Take this coil and just reverse everything we did before. I'll plug through. And what we're going to do here, right in this little rubber grommet, remember if we kept the rubber grommet in there, we'd have to slide this whole thing out and have this end of the spark plug pull through the grommet, it'd be a pain. So what we did, we just pulled the whole grommet out and made life a lot easier to come through. But sometimes to get that grommet back in, a little bit of a pain also. Grab a little WD-40, a little bit of light oil, and just lubricate this section of the grommet. This way when you go to install it, right into that hole, you could usually wiggle it back in, pull it through from the other side, and it'll pop right in, make it a lot easier. Okay, so we're going to go ahead and try to get that popped through. We're just about there. Sometimes you may need to just pry a little bit, not too much, because you don't want to clip the wires. So we'll just go ahead and finish popping it through over here. Okay. The grommet in place. Okay, so once we route that through, we get this tucked under the flap, and we put our coil in place. Go ahead and put those screws back into place. Again, any fasteners that we use to reassemble the engine, we're going to use a medium strength thread locker, like a blue Loctite. And we're going to go ahead and install these ignition coil screws. The older Wacker jumping jacks, the BS45, BS52, BS60, BS62Y, etc., used a different style ignition coil, and you're able to use a regular spark plug, like a regular Champion L86, and they run just fine. The newer style Wacker jumping jacks, the oil injected and things like that, they have a new style ignition coil. There's a lot more circuitry inside, and they require a resistor spark plug. If you use a standard spark plug when you should be using a resistor plug, you will, in most cases, notice it's not going to run right. It may not idle right, it may not accelerate right, and once it does it, your clutch engages and it starts compacting, you may notice erratic jumping because the motor is not running well. If you've got one of the newer machines, you've got to run the resistor style spark plug. You'll notice a very big difference. Okay, so we've got our coil on. The screws on the coil are going to get torqued to 2.5 foot-pounds. Again, we're not torquing ours or Loctiting ours because we're going to use this for another class. Once we're in place, you want to go ahead and bend this tab down. Get my hammer. And we'll just tap it down a little bit first. Once it's in that little notch, get your screwdriver on it and hit it till it's flush with the case. Okay, we're going to do the same thing with the small ground wire. I'm going to get that routed through. We'll get that in place. We'll hook it up. Smaller screwdriver. We'll just give it another little pop. Okay. What I like to do when I do these, just because if that ground wire gets loose and starts flopping around and hits that flywheel, it's going to ground out. Normally what I do when I get to this point, I'll take a little bit of a silicone, just a little bit, and squirt it into that groove and make sure it's in there holding down that wire. Because just because it's clamped here doesn't mean it can't come free over here. Okay, so I'll normally put a little bit of RTV, a little bit of silicone or something, squish it in there and let it dry. This way that wire is not going to be the problem next time around. Okay, so our coil is on, our wires are routed, our tabs are pressed in. It's time to install the flywheel now. We've got the flywheel. The flywheel is keyed. We'll line up our key with the key slot here. We've got our washer, we've got our nut. Okay, this nut is torqued to 41 foot-pounds. Remember, don't use a screwdriver. You'll break your flywheel, you'll damage your coil. You could use your screwdriver on that top hole and torque it that way. Do not use an impact. If you use an impact, that nut is very thin. There's maybe 5 or 6 threads. If you do it too hard with that impact, you're going to strip the threads on that crankshaft. You'll do this whole thing again. Okay, so we're going to stay away from the impact. You could remove it with the impact. Don't install it with the impact. Okay. On the older style WM80s, they didn't have little inserts on the ignition coil. And there was actually a little bit of room to adjust your coil for the air gap. Standard air gap, use your feeler gauge, right there at the magnets, between 13 thousandths and 16 thousandths of an inch. Okay, so you'll set your gap, then you'll snug those screws. The newer ones, these coils have little inserts, and there is no adjustment. Once they pop into place, there is no moving it, there is no adjusting it. So you don't have to worry too much about an air gap on the newer style because you cannot move them. Okay, that's why we did our coil first. Okay, so that's on, that's torqued. Our flywheel side is pretty much done. Now we're going to move on to installing the piston and cylinder assembly. Okay, we're ready to install our new cylinder assembly. We got our gasket here. Just a quick note on pistons and cylinders. For the most part, the piston and cylinder assembly is pretty inexpensive. If you've got to do an overhaul on the engine, in just about every case, it's really worth putting a new kit in. That's going to be the new piston, new ring, new cylinder. It's not expensive. It's worth you not having to do this procedure again in 3 months from now. Having said that, if you want to just do rings, if you want to just do piston, or if you want to just see if your piston and cylinder are within limits or not, there are a couple of things for you to check. The first thing is ring end gap. It's pretty much to tell you if your rings are worn or not worn. Okay, it's just a standard piston ring, and what you're going to do is you're going to install the piston ring into the cylinder. Okay, the bottom of the cylinder doesn't see any wear. The top of the cylinder, say from here up, where the piston and the piston is sliding up and down the whole time, sees all the wear. The very bottom doesn't see a lot of wear. So to determine if your problems, if your rings are within limits or not, you're going to go to the non-worn area at the bottom of the cylinder. So what you want to do is you want to take your ring, install it near the bottom of the cylinder where there's no wear, and you want to measure that gap on the ring. The distance between the two ends is called the ring end gap. Okay, a new piston ring has a distance of 8 thousandths to 16 thousandths of an inch. So if you're within those limits, you're in perfect condition. It's got a maximum allowable gap of 47 thousandths of an inch. If you're right around 47 thousandths of an inch, your piston rings are pretty well shot. Time to replace. The next thing you want to do is you want to see if your cylinder itself is worn or not worn. There are two things to check for. One is the obvious. Is it scored? Is it scratched? Are there any obvious issues inside the cylinder? We get a lot of calls saying, hey, my cylinder looks fine, just send me rings or just send me a piston. And 2 weeks later, they're trying to order a cylinder kit. Just because your cylinder doesn't look damaged doesn't mean it's good. So the way you're going to check the cylinder itself is checking ring end gap again. You could take your old ring or a new ring and you could put it into the bottom just like we did, and we can measure that gap at one end of the cylinder. And then what you could do is take a piston and just force that same ring all the way down, or as far down as you can get, and measure the ring end gap on the other side of the cylinder. Okay? Now the difference between the ring end gap on the bottom of the cylinder and the distance between the ring end gap on the top of the cylinder should not exceed 8 thousandths of an inch. If the gap changes more than 8 thousandths of an inch, your cylinder is worn. It should be replaced. Okay? So that's the quick, easy way to check if your cylinder's got an issue or if your rings have an issue. That being said, we're going to go ahead and install this cylinder assembly. Here's the cylinder that we removed. Here's the piston, pin and connecting rod. Okay. Now the first thing we're going to do when we go to install this piston is put the piston in the right direction. On the top of the piston there's going to be an arrow. The arrow points towards the exhaust side. And the reason for that is when the arrow is pointing towards the exhaust side, it's going to put the ring ends on the other side, and that's going to make sure the ring ends aren't on the exhaust side, because if it's on the exhaust side, as it goes up and down past the port, those little ring ends can get clipped by the port, break your rings, damage your piston and cylinder. So in order to keep the ring ends on the opposite side, you keep the arrow on the exhaust side. Okay? And remember, our exhaust side, we wrote our little note, it rubbed off by now, but our exhaust side was noted here, so we're going to put the arrow in the direction over there. Okay, so first thing we're going to do is put our new needle bearing into the connecting rod. We're going to put our arrow We're going to put our needle bearing into the connecting rod. We're going to take the piston, slip it over the connecting rod with bearing. Right now, if you had some 2-cycle oil, you'd actually want to put a little bit of oil around this bearing when you slip it in, just to get a little lubrication in there before we start up the motor. We're going to go ahead and put the pin through. And I'm going to try to align the pin through that connecting rod and bearing. Push it through as much as you can. Okay, we're going to take a small needle nose or a screwdriver or whatever it takes to take that pin and just finish driving that pin all the way back till it seats against the clip on the other side. Once that's all the way in, we just have to install our clip. So we're going to go ahead and install that little clip. Once I get it started, I usually put my thumb over it just in case it pops out, I don't lose it. I'm going to push it in till we hear it snap. Once it feels like it's solidly in, I usually take one end of the clip and just rotate the clip around a little bit. This way I can visually see that the clip has been seated inside the groove of the piston. Once that's in, we're ready to go. We're ready to install our cylinder. We're going to go ahead and install our gasket. And we're ready to put our cylinder on. There's 2 tools that we're going to use to help us guide this cylinder on without having a problem. The very first thing, we sell a piston ring compressor kit, and it comes with a little tool like this. This is a blocking tool. It slips over the connecting rod, and when you rotate the engine, it stops the piston from moving around. Now you can easily work with that piston without flopping all over the place. Okay, so that's the blocking tool. The next thing is a ring compressor tool. Most of the time, if you don't have the rings aligned right and you try to jam them into the cylinder, you're going to crack rings. Once you break the rings, you got to stop, order new rings, whatever the case may be. So we're going to use this little device right here. On the rings itself, let me show you on this piston right here. Opposite of the arrow, on this side of the piston, there are 2 pins. These 2 pins are where the rings are going to wind up going. Okay, there's a little pin there, and if you look at the ring, the end of the ring has a little notch. These rings, when installed, are going to align right where the notch is. Okay, but when we go to put the piston into the cylinder, we need to compress it in order to get into the cylinder. So that's where this tool right here comes into play. We're going to slip it over the rings, and when we squeeze it, it'll compress the rings. Okay, so that's what we're going to do now. We're going to align the ring ends over the pins, and we're going to compress it. Remember, this was our exhaust side, because the exhaust side is higher than the intake side. We're going to use our little tool, and when you compress it, just leave a little bit of the piston exposed. This way, when the cylinder goes on, it'll catch and you know your alignment is good. So we've got the piston rings compressed and we've got the cylinder ready to go on. Okay, we'll rotate. We'll align our gasket again. We'll rotate the flywheel until the piston is solid against the base. We'll put our cylinder right on top of the piston, and we'll just start tapping down the cylinder. You could remove the tool. The rings are compressed. You could slide the cylinder down. Now you could rotate your flywheel up. You could remove your blocking tool. You can align your gasket better. And you can slowly rotate your flywheel all the way down. Make sure your gasket doesn't get sucked in there. sometimes just take a little wiggling and a little adjustment. Don't tighten anything, don't force anything until you can confirm your gasket's not been moved or damaged, your cylinder is flush. Give that cylinder, give that flywheel a rotation or two, make sure everything's moving smoothly and well. Now we're ready to put in our new bolts. Again, I like to use new bolts because old aged bolts in combination with an old Allen wrench or socket head wrench sometimes don't get the best fit. And when you're going to remove the other ones, sometimes they could round out. And if you get a rounded out bolt way down there, it's not as easy as you would imagine to remove. What you'll wind up having to do is get a drill bit all the way in there and keep drilling until you drill the complete head off. And then when you pull your cylinder off, you'll have what looks like a stud popping out of your crankcase. It's not an easy way to go. We sell a complete engine overhaul kit that includes 4 screws. Definitely the way to go. If you don't get the whole complete kit and you only buy a piston and cylinder, do yourself a favor and get new cylinder bolts. Okay? So once again, a little blue Loctite on these screws. Okay, you're going to get them finger tight. You're going to grab your torque wrench. You're going to crisscross them, and you get torqued to 7 foot-pounds. Okay. Once they're torqued, your cylinder is done. We are just about done here. Next thing we're going to do is let's put our boot back on. If this is a little snug, a little bit of WD-40 right in this boot, and just slide that boot right over it. Okay, so the boot is done. We're going to go ahead and put our heat shield back on. Put our bolt back on top. Okay, and put our carburetor assembly back on. Get our gasket in there. Put that carburetor adapter plate. Now you just use this washer here. Just a little flange nut, 2 little flange nuts is all it takes to hold this on. We're now ready to put our cover back on. Okay, that's it. Our overhaul is done. This engine is ready to be reinstalled. I would say if you've got the oil injected engine, there's not much you could do other than add a little bit of oil to your gas for that first tank full of gas. Let you get a little bit more oil for the break-in of this new piston and cylinder. If you're pre-mixing and you don't have oil injection, just put a little more oil for the first tank. Just let this thing break in. You got a lot of new components in here. A little more oil goes a long way. That's it. You're ready to put your clutch back on, install it onto your machine. Once it's on your machine, you could hook up your cables and your air intakes and everything like that. You could put your muffler back on. Remember to use a thread locker. And if you're not sure of your torques or values, give us a call with your model. We'd be happy to look that up. Okay, I hope that was helpful. If you have any questions on overhauling your WM80 engine, please give us a call. Toll free 866-611-9369. My name is David with DHS Equipment, and thanks for watching.
Do you need concrete cut-off saw parts? Stihl, Wacker, Makita, Husqvarna, Honda engines and parts? Wacker equipment and parts? DHSequipmentparts.com is for you.
DHSequipmentparts.com